some question about containers. The first one is how a container run. How a container run. And the second is how resources like CPUs and memories are shared or contained between containers. CPUs, mem are shared or contained between containers. Right. So I try to explain answer two questions. I will dive in container anatomy. Okay, so let me scroll down a bit. Okay. Let me draw from the bottom. We have hardware like CPU or memory, I mean RAM. Let me clean it a bit so it looks nicer. Okay. Okay. And on top of it is a Linux kernel. So let me change the color. Linux kernel. That is the most important components. And inside Linux kernel, there are control group or C group. C group. The second important component is namespace. Namespace. The next one I want to say is the union file system. Union file system. And other components. Others. Okay, I'll explain the functionality, of each component later on. On top of it, we have another layer, which is container D and run C. This is a container runtime, C runtime. And on top of it is Docker engine. Docker engine. So it has APIs and you can call, create image, run a container, and finally you can run some container 1 and container 2, for example. Okay, so now I explained. The first one is the namespace, right? Namespace. So what is the functionality of namespace? So namespace help separate a file system between container 1 and container 2. Let me draw a file system. So this is the file system which only container 1 can see. This is a container 1 C, right? And I draw another file systems. So this is another file system, actually virtual file system, container 2 C. So they are separated, right? The second component is C group. So C group helps separate or contains CPUs, memories between container 1 and container 2. So let me draw it. For example, for container 1, we can set a CPU share 1K. CPU container 2 got CPU share 2K. Right? I explain later on, what the number means, but it's a separate CPUs and similar for MEM. It also set limit. For example, container 1 CPUs period 100,000 microsecond and CPU quota 10,000. It means 10%. So what does this mean? It means container ones can use at max 10% of CPU cycle. Okay, and similar we can set so that container 2 at max can use only 1% of CPU cycles. So you can change CPU memories, CPU limits, how much container 1, container 2 can use. Right? I explain later on the difference between request and limit. They are different. And another component is union. So union help you build a container image by a layer, right? It layer and it union. So I will explain in another videos. Next one very important is this component, container D and run C. So it help you pull image and spawn or launch image and other stuff. It means it manage container life cycle or life cycle of container. Okay, so we sum up. I explain, C group, it contains resources like CPUs, memories, namespace, it's separate. File system, unions, union file system help you build container image. Container D, it spawns or launch image. It manages life cycle of containers. So now let you give a demo about CPU limit. Okay. Before going to the demo, let me explain. I'm gonna scroll down a bit. Okay, and I explain CPU limit and request, right? So I assume that I have two container, container 1 and container 2, and the first one about request. So what does that mean? I can set for container 1, container 2, and I set CPU share, CPU shares like 1K, CPU share 2K. So what does it mean? It means that this is a relative weight about CPU usage, right? Under normal conditions, but we have to notice under normally when there are plenty of CPU resources. So both container 1, container 2 can use as much CPUs as they need. For example, each of them can use up to 50% of CPU usage. However, under constrained CPU limited or constrained, CPU 2 can use or consume twice times CPUs at container 1. So that is a key point, twice times. The second is about limit, right? Limit. So what does limit mean and how to set it? Well, I set it via two parameters, CPU period. By default 100,000 microsecond, and CPU quota. For example, for container 1, I set CPU quota about 10,000. So it means at max or at most, container 1 can use up to 10% of CPU cycles, right? And similar for container 2, I can set up quota 1000. It means 1% of CPU cycles. If the container 1 try to use more than 10% of CPU cycles, it will get throttled. It means it has to wait until next period. Next period to get as max 10% CPU cycles. I explain detail in another videos. So now let me give you a demonstrations. Okay, so I gonna launch 1, 2, 3 containers, and I set different limits. Container 1 can use at max 1%, and then container 2 use at max 2%, and the last one can use maximum 10% of CPU cycles, right? But under normal conditions, we're gonna see that they can use same amount of CPUs. However, when I do pressure test, I mean I send a lot of requests to container 1, container 2, and 3, and we see that at maximum they can use 1%, 2%, 10% of CPUs. So that is the meaning of limits. So let me check. Let me get the image ID. So this is the image ID. Which one? And now I'm gonna launch this one. And I paste the image ID here. Okay. Okay, and I'm gonna launch the second one. Let me copy this one. Image ID. Okay, and I'm gonna launch the second container. Launch it. And I launch a third one. Let me copy the container ID, and I'm gonna launch the last one, but I need to I change the binding port to 82. Okay, and launch it. Now I'm gonna monitor, so the first one running, the second one running, the next one running, and I will check. Okay, so at normal conditions, when there is no request, no load, all containers can use same amount of CPUs, about right 1.15% of CPU cycles. And now let me load that is. Let me can I split it? Okay. So first one, I send a lot of requests to the first container, right, port 80. So run. Okay, and you see the CPU's usage, ramping up, but less than 1%, right? Less than 1%. So that is the meaning of limit. So let me try another one. Now I'm gonna send a lot of requests to the second container. Okay, and yeah, you see the second container can use at max 2% of CPU cycles. Oh. And now I stop. Yeah, it go down to 115. And now I'm gonna send a lot of requests to the final containers. So it can ramping up to 10%. Yeah, we see maximum. It can use up 10% of CPU cycles. So that is about CPU limits, right? So we wrap up some very important when container runs. C group control the CPU's memory limits. This is very important. Namespace, it separates file system between containers. It controls what container a container can see, right? And container D gonna spawn image, manage life cycle of container, and finally union FS, which help us build container image consists of multiple layers. So that's all. Thank you.